Hello everyone. In today's lecture, we are going to learn about some applications of trigonometric functions. We've already touched on some word problems using trigonometry, but we will extend them to apply a right triangle trigonometry to find the height of buildings or to measure distances or to find the angle of elevation or measure the angle of depression, which we have already learned about before. The other application is in the area of navigation, and for that particularly we have to know how to interpret bearings. So I would like to spend some time explaining all that in this lecture. I expect this lecture to be relatively shorter than some of the other lectures. We will start by learning to solve for a right triangle. What we mean by solving for a right triangle is that you will be given the figure of a right triangle with perhaps information on one angle measure and the length of one of the sides of the triangle, and you'll be asked to find the length of all other sides of the triangle as well as all other unknown angles in that triangle. We will also talk about a real-world application of such right triangle trigonometry. The second area of application is solving problems involving bearings, and that has to do with guidance and navigation, especially related to the north, south, east, west bearings and how to interpret the bearings given to us. And that is what I plan on explaining in more detail in this lecture. So let's learn about solving right triangles. Again, what solving a right triangle means is finding the missing lengths of its sides and the measurements of its angles. So we first have to be given, or we have to first draw a right triangle based on the information provided to us. We have to label the different angles correctly using the convention of labeling right triangles. We also have to label the sides of the triangle with the correct notation. So we will label right triangle so that side A is opposite to angle A, the side B is opposite to angle B, and the side C, which is also known as the hypotenuse in a right triangle, is opposite to the right angle in the triangle. Now, when solving a right triangle, we will use the sine, the cosine, and the tangent functions rather than their reciprocals. The first example is about solving a right triangle. Here we've been given a figure of a right triangle. All its sides are properly labeled as well as all its angles. The information given to us is let A equal 62.7 degrees and the side A equals 8.4. Solve the right triangle rounding lengths to 2 decimal places. Therefore, in this right triangle, we've been given information on angle A, and that is 62.7 degrees, and side A has a measure of 8.4. Therefore, we have to find all the unknown sides and angles of this right triangle. We have to find side B, side C, which is the length of the hypotenuse, and we have to find angle B. We already know it's a right triangle, therefore angle C is 90 degrees. That is already known. So as far as angles are concerned, we have to find the measure of angle B. So we will start by finding angle B first. Now in a right triangle, because we know that one of the angle is always going to be a 90-degree angle, the sum of the two acute angles will always be 90 degrees. The two acute angles in any right triangle are complementary. What are complementary angles again? When two angles add up to a 90-degree measure, they are considered to be complementary angles. Therefore, to find angle B, all we need to do is subtract 62.7 degrees from 90 degrees. We do not need to sum 90 degrees plus 62.7 degrees and subtract the sum from 180 degrees to find angle B. All we do is subtract 62.7 degrees from 90 degrees and we will get the angle measure for B. Let's pull up the solution. A plus B equals 90 degrees. The two acute angles in a right triangle will always be complementary angles, and because of that, B can be found by subtracting the measure of angle A from 90 degrees, and that's what they've done here. 90 degrees minus 62.7 degrees is 27.3 degrees, and that is the measure of angle B. Now we have to find the length of the two unknown sides of the right triangle. First, we'll start with finding the length of the side B. Now they've used the tangent function to find the length of side B, because now we know what the angle measure of B is. It's 27.3 degrees, and we know A. So this is the opposite side to angle B, and A is the adjacent side to angle B. So opposite over adjacent is tangent, so we form our equation with the tangent function. So tan of B equals the side B divided by A. Tan of 27.3 degrees is equal to B divided by 8.4, which is the measure of side A. So we're just plugging in the values here, the known values, and then we solve for B. To solve for B, we multiply both sides by 8.4, and we end up with 8.4 times tan of 27.3 degrees. You have to use your calculators to evaluate this. 8.4 times tan of 27.3 degrees is approximately 4.34 units. Again, a reminder that when you're using your calculators, make sure it's in the degree mode when you're working with angle measures in degrees. Now we have to find the measure of side C. For side C, we form the equation using the sine function. So to find C, we have to use one of the acute angles to form our equation. We know the measure of angle A, therefore sine of 60 is equal to 8.4, which is the value of A, divided by C. We solve for C. We get C times sine of 62.7 degrees equals 8.4. Therefore, C is equal to 8.4 divided by sine of 62, which is an approximate measure of 9.45. And therefore, we have now solved for this entire right triangle. C has a measure of 9.45. B has a measure of 4.34. We know the measures of all three sides of the right triangle as well as all three angles of the triangle. All right? We will now work on an application-based problem to find the height of a building. That is a very common application of trigonometry. It says finding a side of a right triangle from a point on level ground 80 feet from the base of the Eiffel Tower. The angle of elevation is 85.4 degrees. Approximate the height of the Eiffel Tower to the nearest foot. So here, the best thing to do is to draw a figure which will model a right triangle. So here we have a picture of the Eiffel Tower, and it says that somebody is standing at a distance of 80 feet from the Eiffel Tower, and the angle of elevation to the top of the tower is 85.4 degrees. What is again the angle of elevation? When you are standing on level ground and your initial line of sight is a horizontal line, and you have to raise your vision, your eyes, to look at a point somewhere up above, that angle by which you have to move your line of sight is the angle of elevation. So angle of elevation occurs when you are on the ground and you want to look up at something above. And that angle here is 85.4 degrees, and they've given us the distance or the length of this side of the triangle figure from the base of the Eiffel Tower to a point where a person is standing. So given this, we have to find the height of the Eiffel Tower. So here is the height of the Eiffel Tower, and they have indicated that with the letter A in this picture. We have to now form an equation involving the unknown side, the known angle, and the given side. So what function should we use here? The unknown side is the opposite side to the angle. The known side is the adjacent side to the angle. And of course, the angle of elevation is 85.4. That is given to us. Therefore, the trigonometric function with respect to 85.4 degrees is opposite over adjacent, and that is the tangent function. Correct? So let's start pulling up the solutions. Tan of 85.4 degrees equals A divided by 80. We have to solve for A. Multiply both sides by 80 to isolate A, and we get A equals 80 times tan of 85.4 degrees. And when we do that calculation with our calculators, we get a measure of 994 feet, which is the height of the Eiffel Tower. All right. Now again, reminder, do not forget to check whether your calculator is in the degree mode when you're working with angles given in degrees. All right. Here's another example using right triangle trigonometry. A guy wire is 13.8 yards long and is attached from the ground to a pole 6.7 yards above the ground. Find the angle to the nearest tenth of a degree that the wire makes with the ground. So here we have been given the length of two sides of a right triangle. They're asking us to find the angle that a wire makes with the ground to the top of a pole. Here is the picture again. Always draw a diagram. It's going to help you solve the problem. Now the length of the pole is 6.7 yards because the question says the distance from the ground to the pole is 6.7 yards. The pole is 6.7 yards above the ground, in other words. So that's the height of the pole, and the length of the wire is 13.8 yards long, and that is the length of the hypotenuse in this right triangle figure. We have to find the angle that the wire makes with the ground. So that means angle A is what we need to find. Let's call angle A alpha. Again, which two sides are we given here? The opposite side to angle A and the hypotenuse of the triangle. Therefore, we will be using the sine function because the sine function is opposite over hypotenuse. We have to use the two known sides. The angle measure is missing. That's what we need to find. So we better be given the values of any two sides of the triangle. So next step will be to come up with the equation. Sine of A equals 6.7, which is the opposite over the measure of the hypotenuse, which is 13.8. Now here we are finding the angle measure whose sine ratio is 6.7 divided by 13.8. Now you have to use your calculators here. You have to use the arc sine or the sine inverse button on your calculators to find the measure of angle A. Inverse sine of 6.7 divided by 13.8 will give us an angle measure of approximately 29 degrees. So angle A has a measure of 29 degrees. Therefore, the angle that the wire makes with the ground is approximately 29 degrees. All right? We will now talk about trigonometry and bearings. Now, this is a concept used in the field of navigation and surveying. The term bearing is used to specify the location of one point relative to another point. Therefore, to locate a certain point anywhere in this world, we use what's called the north-south line as a reference point. Just like for standard angles, we use the initial side of an angle as the reference point to measure that angle, the positive x-axis. That's the fixed reference point, and then we measure the angle relative to the positive x-axis. That's for standard angles. In the world of bearings, our reference point is the north-south line. The north-south line always runs vertically up and down. So north goes up and south is at the bottom, and the east-west line runs horizontally. east is to the right of the north-south line and west is to the left of the north-south line. Now, when we describe the bearing of a location, we always start with reference to the north-south line. Therefore, the first letter of each bearing will either be N or S. So let's say we have N as the first letter, north, and then there will be an angle value given to you. So right after N, you will be given an angle value which is, let's say, 25 degrees. So north 25 degrees tells us that we are making an angle of 25 degrees from this point of intersection between the north-south and the east-west line. However, it could be to the west or to the left of north. So for that, we have to be given another measure which is E or W, east or west, right? So to determine whether the 25-degree angle relative to the north-south line is to its right or if it's to its left, we have to be told whether it's east or west, correct? So if it's north 25 degrees east, that means the angle goes like this, right? It goes like this. And this angle is 25 degrees. North 25 degrees towards the east, which is to the right. Let's take another measure, south 30 degrees west. So that means we are at a position along the north-south line. And from the south, we make a 30-degree angle towards the west. So that means it is an angle of 30 degrees from the south going towards the west. Going towards the west, this is a 30-degree angle. So that's how we will be interpreting bearings given to us. So next, we will go through some more information on how to interpret bearings and then we'll work on an example problem. Here's some more explanation on how to interpret bearings. It says if the acute angle is measured from the north side of the north-south line, then we write north first. So the reference point is the north side of the north-south line. We write north first. Now, in the notation of a bearing, the first letter will always be N or S, then an angle measure followed by east or west. So first it is N, and then we write the measure of the acute angle, whatever it may be. And then if the acute angle is measured on the east side or to the right side of the north-south line, then we write east last. So it's north 40 degrees east is what we have in this picture. So that means the bearing from O, which is the point of origin, the point of intersection between the north-south and the east-west line, is north 40 degrees east. That means we started from the north side of the north-south line and we turned an angle of 40 degrees towards the right, which is also the east in this picture of directions, right? If, on the other hand, the angle is from the north line going towards the west or going towards its left, then we still start with N as the first letter. If the acute angle is measured from the north side of the north-south line, then we write N first. Second, we write the measure of the acute angle, and if the acute angle is measured on the west side of the north-south line, in other words, if it's measured to the left of the north-south line, then we write W last. So this angle in the picture is north 65 degrees west, right? Let's look at the case of the bearing in this picture here. We see that the angle made is with reference to the south side of the north-south line. So it starts from the south side, then makes an angle of 70 degrees and moving to the east side, moving to the right of the south side. Therefore, we start with S as our first letter. So to write it in the notation of the bearing, we start with S and then the angle measure. The middle value is always the measure of the angle and then in which direction from south is the angle being formed, is the angle being located, so to speak. So south 70 degrees east. All right, so here it says if the acute angle is measured from the south side of the north-south line, we write S first, then we write the measure of the acute angle, in this case at 70 degrees. If the acute angle is measured on the east side of the north-south line, then we write east last. Finally, let's go through this exercise of finding the bearings of the different points given in this diagram, A, B, C, and D. So the first one says, what is the bearing from O to D? Now, O to D is this angle here. We always start with N or S. We cannot start with E or W, with east or west. So it has to be south. So we start from the south. And then the angle is starting from the south side of the north-south line and stopping at this location D. And that angle measure is 25, so we better write that. S 25 degrees, and then it's towards the east. Therefore, we write it as S 25 degrees east, correct? So it says point D is located to the south and to the east of the north-south line. The bearing from O to D is south 25 degrees east. What about the bearing from O to C? So O to C is this point here. Now the angle measure that they've given to us is with reference to the west side of the east-west line. That angle measure is 75 degrees. However, when writing in bearing notation, we cannot start with west. We cannot say west 75 degrees south. We always start with the north or the south side. Therefore, we start with south, S, correct? And then the angle measure has to be with reference to the south side. So we don't know what this angle measure is. We've been given the angle measure on the other side, which is 75 degrees. Now keep in mind that the north-south and the west-east lines run perpendicular to each other. That means the angle formed is at the intersection is 90 degrees. So if we subtract 75 degrees from 90 degrees, this entire angle is a 90-degree angle. If we subtract 75 from 90, we get a measure of 15 degrees, and that is what the angle is going to be. So S south 15 degrees going towards the west side, going towards the left, which is the west. Therefore, we write S 15 degrees west. The answer is point C is located to the south and to the west of the north-south line. The bearing from O to C is south 15 degrees west. Now, even though they haven't asked us to find the bearing for point B, you should be able to tell by now that the bearing for point B is north 40 degrees west, correct? And similarly for this point A, you have to subtract 20 degrees from 90 degrees because the bearing has to be with reference to the north side. Therefore, this is going to be north followed by an angle measure which is 70 degrees, right? 90 minus 20 degrees is 70 degrees. Therefore, this angle here is 70 degrees and then east. All right, so now we have the bearings of all 4 points given in this picture.